Hello future tech leaders, I am Sindhuja. Based on my own experience, I know that learning the right skills can shape our future. What if I say learning was as thrilled as the tech world itself? There we go. A cloud foundation, that's exactly what you will experience. From day one, you will be immersed in the interactive sessions and expert-led courses that covers most of the widely used technologies in the zone of data science to cloud computing, which brings more light to the life of a techie. I'm so excited to help you and unlock the true potential of a technology. Well, then why to wait? Let's see what it unfolds.
Now, before I start with this, let me start creation of Cosmos DB because it takes slightly longer. While we do our discussion, we will be able to get this resource ready. Let me start with this. Whatever name you want to mention over here for your data store at Cosmos DB and here depending upon what is the API that you want to use. You want to use Document DB or SQL API, Mongo API, Cassandra or Gremlin API. You can choose between any of these APIs that we have available. In my case, let's go for Document DB or SQL. Let's take location as Southeast Asia. Let's go here. You can go for provision throughput or you want to have a serverless. It's up to you. Provision throughput means this is a fixed amount of resource which I want to use in terms of read units per second. Now what is this a use? I will come to that section as we go ahead. In terms of geo-replications, multi-region rights. If you want, you can select these options over here. We leave this blank. If need be, we can change these resources later. Same aspect you see here. Once again, do you want this database instance to be within a specific network or with all networks? Let's use LAS over here for a backup policy. In terms of encryption, I can use service managed key, which is a default one within Microsoft. Or I can upload my own key from on-premises environment. Let's start the creation process. It says this will take around 8 minutes. Much faster. At times it takes around 20 minutes to create that environment. While this is creating, let's go and discuss about Cosmos DB. As far as Cosmos DB is concerned, or if you recall the previous discussions that we had, we said there are different types of data to be stored. Not all data can go into SQL database. Not all data will be RDBMS relevant information or RDBMS relevant details. Those things cannot go into SQL database, right? And secondly, in today's world where we are looking at polyglot persistence, which means depending upon what is the best kind of storage mechanism for a given data type, you should use that kind of data store over here. If it is a key value pair, it should go into a NoSQL data store which is specialized for that. If you have JSON documents, it should go into a data store relevant for that, correct? Through that, what you will be able to do is you will be able to get the best performance out of it. I know we have been saving a lot of data within our DBMS as well, which is not meant to do. when you have remote blob storage within SQL Server. Because earlier what was happening is people were not thinking anything beyond databases. Anything and everything has to be as part of your database, SQL Server. But that's not true. And that's the reason why Microsoft was. While Microsoft was struggling fitting everything into SQL Server, MongoDB and others, you had a completely new series of data source there. If you are looking at schema, less data storage, you can go for storage account tables. Or you can go for your Cosmos DB APIs. If you look at your table storage as part of table storage, here I can store large amount of data which is in terms of schema less. Schema less key value pair. As far as the key is concerned, once it comes to table storage, the key actually is a composite key, which is using combination of partition key and row key. Along with that, the third column being added by Microsoft is the data timestamp. Now, along with these composite keys, what you have as a value can be any number of fields that you want to create, any number of columns that you want to create, and it could be a staggered way, which means the first member, if I look at Azure table, the structure over here, like I said, is key value pair. As far as the key is concerned, there are three members over here. One is partition key. Along with this, you also have to mention a row key. Along with this, what we don't have to mention. Microsoft does it for us, which is keys tab. This is the key section. As far as the value is concerned, the value over here is schema less. You can create as many number of columns as you want. Say each row can have different set of columns. Right. Each row can have different set of columns. Now the question will be, in what scenarios am I going to use this? You are saying the key partition, key row, key timestamp remain same. But as far as the other values are concerned, on every row these values can change. What kind of data store I would want to go for? Or which kind of applications would use some kind of something like this? If you look at something like, I want to store employee contacts. Now each employee can have multiple details, right? Each employee can have multiple phone numbers, different set of addresses, different set of experiences, right? If I want to store all that information, what is the kind of schema which will be required for it? If you take an array, or you say every column will be an array, right? But what type of array? Numeric array, string array. If you say everything is generic, if you make everything generic, or if you make everything string, in that way you are not creating any schema, right? At end of the day, this is what you will achieve. That is a schema list where you allow the user and how many columns do you want to store. If the user has 5 mobile phones or 5 mobile numbers, the addresses, you will see lot of websites today, even job sites which I am talking about. It keeps you giving that plus symbol. Add one more experience. Add one more experience. Right? Now, if you look at a database behind the scene, What will be the database structure? How many columns are you talking about? And if you are saying that I will not store that information into a SIM table, I will take a separate table for it. Right. Which means you have to perform joins. Right. When you are retrieving that data, you have to perform those number of joins, which will again deplete the performance of your application. Right. You have to be very careful while you are, and you don't have to do this. You don't have to perform those number of joins because you have options available where you can store any amount of data for that specific user. And again, I am saying out of 1000 users. This could be a scenario for 5 or 10 users only. But for that 5 or 10 users, you have to create many tables. Right? Now that becomes a big issue. Why do you need to change the entire architecture just for a specific set of people? In that case, go easy by using something called as Azure Tables, where you can have schema-less table storage. You don't have any kind of joins, no foreign keys, no stored procedures. It's denormalized data for says. Now the next question over here would be, if it is schema-less, which means I cannot write SQL queries over here, which is true. You can't write SQL queries over here. Now how do I write? How do I connect to it? Or what is the ways of inserting records or retrieving values? You can make use of OData protocol. OData queries you can write, or you can use your link queue queries over here. Using these resources, you will be able to work with it. If you look at the storage over here, you have your storage account, like one we have already have. Within that you have your tables, respective entities that you would want to create. So Bat, I have a question. Go ahead. For example, if we create any web application and the front end, and can we connect this to the Cosmos, to the front end and try to insert the data? Your voice is pretty feeble. Can you come closer to the mic? Can we build a front-end application and connect the Cosmos DB at the back? That's what we do the OData connection. You can do that. But that's not how the architecture should be. What you should be doing is, you should have your data access layer. Your data access layer should be connecting to your SMOB. That's how you should do it. Data access layer. What is data access layer? When you look at multi-layered applications or multi-tiered applications, you would have your services, your APIs which is connecting to your Cosmos DB. And those services are being consumed by your web application. That's how it should be. But yes, you can do that. Here, if you look at your storage account, I have one more question. Once we have a data access layer, create a front end and back application in a JSON format at the back. I need to get the last part. Can you repeat that? Will the entire data? You will be in a JSON format. Not necessary. When you look at Cosmos DB, the reason why it is taking 8 minutes over here is depending upon what is the kind of format that you have chosen. It will create the entire environment accordingly. If you go for Cosmos DB and you go for a table API, it will not do. It will not store data into document into a JSON format. The final format that it stores is an atom format. What is that? Atom. If you select MongoDB, Cosmos DB creates a MongoDB cluster behind the scene. If you choose Cassandra, your Cosmos DB will be behind the scene. Will you create a Cassandra environment? And that's why it takes time. It builds that complete infrastructure based on the API that you have chosen. I'm still waiting for that actually, because I'm still confused whether this is really a service on top of a real database like MongoDB or Cassandra or Azure Tables. Like, is it a kind of layer on top of that? Or is it a real database? I'm kind of waiting for that. It's a real database. If you are comparing this with storage account, what it does is storage account basically is like an interface where behind the scene you have all the 4 services: tables, queues, blobs and files. Cosmos DB is not like that. Cosmos DB is basically when you choose any of these APIs. Your table API or Cosmos, your MongoDB API or DocumentDB API. It creates a complete environment behind the scene based on what value you have mentioned. Which means, if you have created an instance using MongoDB, Cosmos DB instance, using Mongo, you cannot store Cassandra details inside that. You cannot store stable API details inside that. If you store table API, you have to create another one. Can I assume like I'm living before this cloud environments? My one client, he tried to save all the data in the Oracle, and another client, he used to class or store in the SQL. All I had to do is like, I had to create an API. That API I can take care which database they will connect. It can pass. It's a kind of right. Cosmos. That's a wrong assumption here. It's not like data access. As I'm telling you, Cosmos DB is a database in itself. When you are creating this Cosmos DB instance, right, when you, say for example, when you create a SQL Server instance, do you know, are you going to store employee database inside it? Are you going to store school administration database inside it? You don't know, right? I don't know. That's when once the database is created, then you go and create those tables inside it. Similarly, Cosmos DB, once you create, first thing to do is, but once you go to SQL Server, you know that this will be ID. We miss only. I will create tables only. In Cosmos DB, you don't know. What are you going to create? Based on your requirement, which kind of NoSQL implementation you want to go for? You want to go for a graph database. You want to go for key value, a key value pair or columnar store, or JSON documents. Based on your requirement, you'd say, this is a kind of environment which I want to build. Cosmos DB allows you to build that environment for you. You can. Go ahead actually. Like the more we go into like maybe, we'll get more. You do first complete with tables. Then we go to Cosmo. As far tables are concerned, let me create a table over here within my Azure environment. My Cosmos DB is ready. And then, as far as tables is concerned, I can go to my storage account. Within storage account, let me go to tables over here. Let me add a table like I was mentioning about EMP contact. Now the problem here is I can work with this over here. I insert any records or values over here. To help you with that, I Storage Explorer. Let me go to Storage Explorer. Let me go to Storage Explorer and using Storage Explorer. Let me add a few values over here. Let's see. Partition key. Rook. And let's add properties over here. Department ID or region ID. And the row. Employer. I have added over here. In terms of other properties, I want to mention whatever other properties you might want to add over here. Let me stop with this. Click on Insert. This is one loop which I have inserted within the table. Let me go for the second value. Same department. This is something which is not allowed. I cannot have same partition key and row key. If I inserting this, it will give me an error saying that this is a primary key violation. For the second one, I just want one property to be inserted over here which is valid. You decide for each. What are the properties or what are the values that you want to insert over here? Partition key can be still. This combination has to be unique. That's important. I can have Ali. New set of properties over here. That's what we mean. Shimless can have different set of properties, different set of attributes. And I can store values for that. Does it make sense? Within a storage account, you'll have your entity. Within each, you'll have respective entity. And each entity, you'll have respective properties for it. You'll have for it of tables for each entity that you have within your system. If you look at the value, if you look at the naming rules over here, right? Table names have to be unique, small case characters. They are case sensitive. I already mentioned about these three members: partition key, row key, and timestamp. Partition key could be something like location. And if you look at partition key, row key, these are strings, they are not numbers. By default, you can store numeric values if you want, but these are by default strings. Right. This is a quick look into tables. Let's go into Cosmos DB API. Now, this is a very important diagram. If you see your Cosmos DB, this is what Cosmos DB is all about. Like we were discussing about, what does Cosmos DB offer you? From a user's perspective, right? You will have to decide what is the kind of API that you want to use for communication. One of them. For instance, if you're taking one instance of Cosmos DB, you can either go for Table API or Cassandra or MongoDB or Gremlin. Like storage account, say, once you create any member within the same storage account, your same storage account instance, you are storing tables, queues, file share blobs. It is not true for Cosmos DB. Cosmos DB, you have to take one of them because it has to create that database behind the scene and allow you to work with that API. Depending upon which API you have mentioned, it will create that kind of structure behind the scene. That is key value, pair or column, family or graph, document-based storage or graph-based storage. You don't have to worry about the structure. What you should be worrying about is how do I write my code? What is the type of content which I should store over here, and it will help me work with that. The SLS which is being given by Cosmos DB is whatever global distribution that you have that I have promised. I will help you achieve that. I will help you elastic scale. Right. And if you look at this elastic scale and throughput, what you create as a resource is not server. What you create over here is not a server or a machine. What you create over here is something called as read units per second. Whatever data I am storing, this is the read units per second which I want. These are number of hits or number of reads which is going to happen on my content. That is what we go and store, or that is what you go and mention inside Cosmos DB. Right. And the entire pricing model over here is based on read units per second. How quickly you can read that information. Right. Next, remember that you see over here is guaranteed low latency to 99th percentile, which means fastest access of data. That is what is the primary focus once it comes to your Cosmos DB. Storage of data in any format that you would want and getting that data faster. That's the core purpose of Cosmos DB. You do not have a default R function. If you look at your consistency models over here, now We never thought about consistency model once it comes to SQL database. Because there is only one consistency, which is called as strong consistency. Now, what do I mean by consistency here? Whenever we are inserting data, inserts, updates, deletes, which is happening, right? What it has to do is the number of copies that you have behind the scene. Say 2 copies, that is 2 different machines that I have behind the scene, or 3 machines that I have in each machine. What I am doing is, in each machine I am maintaining same status for the data, right? Which means if the value is being updated in the first copy, unless it is updated on other 2 copies or 3 copies, I will not share that information with the customer, because that information can be a steal information. That information could be a old information, right? That is called a strong consistency. Whereas once it comes to Cosmos DB, there are 5 models for consistency. Depending upon your requirement, you can choose any one of these consistency models, which ranges from strong consistency to eventual consistency, which means eventually all copies of the data will be seen. Now, whatever is being mentioned over here in terms of elastic scale, global distribution or 99 percentile, all these things, Microsoft will give you comprehensive success for it. If you look at your Cosmos DB over here, these are the APIs that we have mentioned and one instance of Cosmos DB. You can use one of these resources here if you want to work with MongoDB. In my scenario, I have to create one more instance of Cosmos DB. Let me stop what you chose while creating the. What did you create while creating the Cosmos DB SQL API, which is not? Which is document DB. If I go to Cosmos DB right now, if I see the options available, I can go ahead, create a container over here, create a resource by default. Where is the Data Explorer? Let me go to the Data Explorer as part of Data Explorer. Here I can see what is the Data Explorer. Within your Cosmos DB, you have your account within that account. If I go to the data, I can create a new database. Within that, I can create a new container. And within that container, I can create my resources. Let me create a database over here. Let me create a database over here as company DB. What is the kind of scale that you would want? What is the number of read units per second that you would want? For 400 read units per second, this is a charge which is an hourly charge. You. New container over here and whatever is the partition key that you'd want to maintain. You can mention that over here now. Whatever resources you are creating, There's no concept of tables. Over here is a concept of documents. I can go to the items section. I can add an item over here. I can upload this item pre-existing data store. Whatever contents you want to create, whatever information that we want to mention over here now, each of these. Now again, this is again schema list. Each resource that you create can have different set of values, can have different set of members over here. Right, and what it will add on top of it will be set of members for referencing these resources. You can add as bin number of members as you would want. Let me add whatever values that you want to mention over here once you have these resources. Now, what is the significance of this member? Select star from C where C.tip location, C.dpt location here again. Actually is not SQL database. It is a JSON based document, but I can still fire SQL queries on top of it. That is, what is the significance of SQL API? That is, what is the significance of SQL API Microsoft? What it is helping you do is using this instance of Cosmos DB. Using the instance of Cosmos DB, Microsoft is allowing us to write SQL queries on the underlying environment. This is an advantage of using SQL API. Along with this, I can also go ahead write stored procedures over here using JavaScript. I can write user-defined functions over here or triggers over here, and each of these things will be similar to what you do for SQL Server. Again, please be careful that the syntax will not be seen like how I showed you for SQL syntax, that for the queries, in terms of stored procedures, the syntax is not same as your SQL. It will be a JavaScript-based syntax. But yes, we can write stored procedures over here. We can write user-defined functions over here. Within SQL API, I can use join queries, join order by group by. I can use all of this. Though the data behind the scene is not into tables, I can still write those queries, and that is an advantage of using SQL API. If you are storing this information using Mongo API, you have to write your Mongo queries. Depending upon which kind of API you have used, that will be the mechanism of communicating with the data store. Does it make sense to everyone? What is the meaning of this API? Does it answer your questions? You still have any? It's a kind of new database. I need to practice this. Sure, because it is too flexible to create a type of database. And the APIs and the rows and columns, it's not fixed and correct. Correct to schemaless, schemaless. That's right. Which API you want to use over here? Right now I'm using SQL API. Depending upon your requirement, you may go for Mongo API, Table API or Graph API as well. Once it comes to high availability of your Cosmos DB, what it actually does is it creates multiple nodes behind the scene, and using these nodes, it will replicate that information, that replicate the data on different resources. When you are looking at this 8 minutes or 10 minutes, and it says this is the reason it creates the entire environment which is suitable for that kind of API, along with the same way, along with that. If you have mentioned global replication, it will create similar kind of environments there as well. Right? Using that information or using that details, it will help you get read units per second or different geographical regions. In terms of SLs that you see, it gives you 9.999% red SL, 8.99% red SL as well, right? Similarly, even for multi-region writes, where you have geographical locations, the data will get written onto all these environments, all those locations. That's confirmed. But whether it will happen at the same time or whether it will happen eventually, that is based on the consistency that you have mentioned. But yes, it will get written, it will be. The data will be updated, that's for sure. Now, in case of any downtime or any issues that we have with any one of the regions, right, that high availability or that resource mapping, all these things will be taken care by, and that's for sure itself. You don't have to worry about it. You don't have to worry about if this primary region is down. How do I use a load balancer for the secondary one? And again, I need not mention it. That is the reason why people would go for a PaaS service, right? Because they don't want to manage all these things, and these things should be given to us by the service provider. This slide basically tells you that whatever is your requirement in terms of high availability, in terms of DR solutions kind of thing, all these things are taken care by cost positive. I already mentioned about the APIs. You have your SQL API, and I showed you some examples of that using SQL queries. Then I mentioned about the table API over here. But for table API, what table we have created was using storage account. It is not inside the Cosmos DB environment. Now, what would be the difference of that? If you create these, take this table inside storage account, you will not get the performance if you want. If you want high performance for your tables in terms of the operation that you are performing, it is recommended that you create this inside Cosmos DB and use a table API for it. For graph-based databases, where you need to create primary, where you need to create the root nodes or vectors, and then respective branches for it, right? All those things are part of your Gremlin API. What we did right now is using JavaScript object notation, and the API that we have used over here is as SQL API. Last point, last one I already mentioned about. If you're writing anything in stored procedures, triggers or user-defined functions, it will be using JavaScript. You cannot use your SQL, PRPL SQL syntax or STSQL syntax over here now. One of the best things that you will see over here. For any of these implementations, whether it is MongoDB or Cassandra, in these scenarios, whatever libraries you have, whatever tools you have, you just have to change the URL. You have to change the URL of it, which means instead, say earlier, we had Cassandra running in your on-premises environment. There will be a specific connection string for it. Now, in your tool for the Cassandra, you will be specifying their connection string. Am I correct? Similarly, in this scenario, you just have to mention the connection string for it changed the connection string from local environment to the connection string given by Azure. That's it. All the existing tools that you have. Everything will work as it is without even a single line of change anywhere, which means what Microsoft is doing behind the scene is they are creating the complete Cassandra environment on Azure, and that's what takes time. When it is creating these resources, it will take time to create that environment and allow you access to that environment. If you look at your Cassandra API, you don't have to do any kind of operations management. The standard format of Cassandra API is being supported over here. In terms of availability, elasticity, all these features are taken care by Microsoft. You just have to create the API, upload your data over here. There are a number of tools which can help you move data from existing MongoDB or existing Cassandra environment to your Azure APIs. Now why are? First off, one more thing very important over here is why are people moving to Azure or cloud-based solutions for new SQL data store, right? One thing we have to understand over here is any of these tools that we are talking about, any of these new SQL APIs that we are talking about. Each of these tools will require storage, right? And especially once it comes to know SQL data stores, the amount of storage required is pretty huge as compared to your structured data storage. While you are storing data into RDBMS, while you are storing data as part of your rows and fixed set of rows and columns, the amount of space taken is much lesser. If you are storing data in the data storage environment, if you go for storage environment where you have large set of data being stored but not in a structured format, the amount of space taken will be much higher, correct? I have seen and worked with number of users where the initially going for no SQL looks easier. But amount of data storage when they look at, and especially when you are creating these nodes, right? Each node you have to replicate that same data, right? The total amount of storage required is huge, and it is difficult for people to survive with this amount of storage options within on-premises environment. And making sure all those nodes are having a higher uptime, right? This is one issue. Now, second important point that you look at over here, after you have stored the data, you will have to make this data available to different applications, different users, via your application. There has to be minimized latency for this. How are you going to make it possible? It should be accessible to users who are accessing this data globally from different locations. How do you make that possible? Data can be available within any of the nodes, any of the partitions, and within the minimal timelines that you have. How do I get all this information and share it with my user? Are you getting it? Storage, compute, networking, all these three things are required when people are working with NoSQL data stores. I am not saying these issues are not there for SQL data stores or structured data stores, but still people have survived for long using structured data storage on premises, but with NoSQL data store it is becoming difficult for them. I have worked with organizations where they have more than 20 to 30 machines just running Hadoop instances and working with MongoDB and running applications which are targeted towards these kind of resources, and still they are not able to give SLAs beyond 6%. Can you imagine that? For these kind of requirements, people have to go for cloud-based resources, whether it is Azure AWS, right, or any such cloud source, right. I have already mentioned about MongoDB. You can have financially backed SS for MongoDB. Once you have uploaded your information here, I can use any of the applications, pre-existing applications, drivers, tools that I have to connect to my Mongo API, right? Here, if you see the third point, keeping applications portable, write applications, don't change the client applications or the presentation tier that you have, your API services, your data access layer that you have written for MongoDB earlier, that will remain same. The only thing which has changed is the data is now not being stored inside the on-premises environment. The data now is being stored on cloud environment. That's it in terms of Gremlin API. Already mentioned that in terms of what I says, edges, respective properties, for it becomes easier for you to fetch that information, fetch those values and deploy it over here. Whatever, I'm not sure if you have worked with Neo4j. Neo4j basically is a graph-based API. There are a lot of technologies which store organization hierarchy, right? Those kind of details. You can use Gremlin API for it. Just give me a moment since I'm talking about scenarios over here. Let's go to Docs Azure Recom here. If I go for Azure Architecture Center, you can look at this URL, a very important one from architecting perspective, which will help you understand in what scenarios should you go for key values tool. What would be examples of this? Somebody like Guru who has been mentioning about that. It will take me time to understand when to use what. I think this information will be helpful, right? Things like data caching, session management, right? User preferences, any recommendations that you have. This is a kind of data that should go into key value pair. This is a kind of data that should go into key value pair. Now, why am I using these examples? Because in these examples, I don't have a fixed schema. In the scenarios, I don't have a fixed schema here. If you look at document databases, your content management, your pages that you are creating, inventory management, and right, these can go. These can be examples of document-based databases. If you are looking at associations or correlations between number of employees, number of team members, building up a hierarchy over here, the example one can see is Graph AP. Right? You want to create social graphs, fraud detection recommendation engines. There are a lot of new applications or a lot of other application scenarios which we know we may not have worked with right now. But today, once the initial steps are being done, the initial data storage is being taken care, right? Every customer will want advanced resources, and for those advanced resources and facilities, then you have to use this NoSQL data stores. If you look at things like your Facebook or Twitter or any such members, none of them are working with RDBMS for all their modules, maximum of their modules. Maximum of the data storage is getting into these kind of NoSQL data stores. You can look at the complete diagram over here, which can help you to decide in which scenario what should be the data store that I should go for. Am I audible now? Yes, no network issue at my side. Yep. Here I was mentioning about, while you may not know what is the kind of data store I should go for. Go ahead, ask these questions to your customer. Or when I say customer over here, customer does not mean the person who owns that business. Customer over here would mean the actual stakeholder, the person who is handling this data storage and in day out basis the DBAs that we have. Those will be your customers, or those will be the right people whom you can talk to. What is the kind of SLS that they have promised? Right. These will be the factors over here that will help you to understand whether SQL API is best for them. RDBMS is best for them. Storage account will be good for them. Right? And like I said, it doesn't mean that once you have chosen SQL database, everything should go inside SQL database itself, not necessary. You can create members over here or create resources across number of members, across number of resources, and you can correlate or you can work with those members together. And that is what we mentioned as polyglot persistence. This was a quick look in terms of what are the options over here. What are the resources available for Cosmos DB? Anyone, any questions over here? Not much. Let me go ahead, showcase few more resources here. Once you are working with these members, right now, what we have done is we have got the database created over here. Within that, we have departments here. Let me delete the database. Let me delete the database here. Let me delete the database here. Let me take up a sample database. Much theory, sorry. Much theory today. We covered much right. Literally a lot. Sorry, you're saying something literally a lot, least a practice. A lot of otherwise, like you can't even connect to the charts. Here what I have done is using this quick start. I have added a pre-existing container over here. Let me go to Data Explorer once again. What it has created using the quick start is it has got the items container. It has got the items member over here within to-do list database. Along with this, it will also allow you to download an application. You can already download a sample.NET application over here which can help you work with this Cosmos DB. Let me extract it over here now. With this application, what you will also see is the required keys, the connection string. Everything is part of this application. You don't have to actually change anything. You can run this application as it is required. If I go to my Solution Explorer, this is restoring the packages right now. I'm done. Let me go to the code over here. There are two sections over here. One is two main files over here. One is programs and second is Familix. Familix basically is the structure. The code over here is the code over here. The code over here is the code over here. The code over here is the code over here. Let's go to our code once again. Here, if you see, by using this code, they are creating a database, which is to-do list, creating items over here, right? And creating every other resource which is required for it. How do I create a database over here programmatically? How do I create a database over here? If you see this part, get demo async. This will create all the resources. Let me comment these last two lines, because this will also delete the resources, clean up the resources. Right now, I don't want to clean up the resources. I just want to create database. Create container inside that. Scale the container programmatically. Add items, query it. And then also do updation. Any normal process that you would want to do with your resources. You can mention that here. Let me save it. Let me execute this. It gives me an error. It says the requested partition key path does not match the existing container items. No issue. What it is saying is, while I was trying to create this resource, I realized that there is already a database being created over here as to-do list and has items inside it. And this does not have the partition key which I am expecting. Either you use that or you allow me to create these resources from scratch. I have deleted this data store, created this database from here, and I will create the same thing by using code. Can you see this? Creation of a resource. Retrieval of values. Within to-do list, I have items. Within items, I have two details being mentioned. And if you see the kind of document that we have, last name, parent, children, and you can have any levels of nesting that you want. The JSON con, what we showed, what we did earlier. Department, which is much simpler and easier. Structure, whereas here, if you see, it is within arrays. You have number of attributes for this. Children, as an array, each child will have pet, which is again an array, and it can have multiple pets. You can have nesting of resources over here. Once it comes to you, if this is your requirement, if this is the kind of content that I want to store, the approach over here should be document-based databases. Does it make sense for you? Thanks for showing this from the creating and all these things from this tool. No problem. Net. See many a time. See, I'm not saying that you'll have to be a developer for this. But if I know, correct, you need to understand the relevance of it. What kind of applications, which kind of projects, this will make sense for me. If I have a complex structure where I am creating data store or I have number of properties, say shipping, billing, within shipping and billing, customer information, customer details, address of the customers, booking location, billing location, actual delivery location. If I have that kind of structure to be stored, it will be easier for me to work with. Document. When you see an array, I'm not sure how many values I will have over here. 15. For these kind of things, you can create your structure over here in your code. And then, depending upon the information given by the user, you can keep creating these resources here. Once I am done with this, programmatically, we can also delete these resources. Let me close this application. Remove the resources as well. Now if I go back to column B, it is empty. Right. This was quick look into Cosmos. What are the options available here? We will stop with this for today. And finally, do not forget to like, share and subscribe to our channel.